This is part 2 of what's the deal with the square root of 3. If you don't understand the stuff in this video, I implore you to go back to the first one and look over what the trigonometry is and then what a phasor diagram is, because we're going to dive into the phasor diagrams here to make it a little bit easier on the math, okay? So we are going to use these phasor diagrams, and to make our life easier, we could assign all of these as 120 volts at an angle of 0 degrees and 120 volts at an angle, volts at 120 degrees. And then this one would be 120 volts at an angle of negative 120 degrees or 240, okay? We could do that, or if you want to make life easier, we could use what the unit circle does. And the unit circle, I love it. It would just be 1 volt. And so we're just going to use a radius of 1 because we like to make math easy when we have that option. Because I promise you, if you use the number 1 right here, and you say that this length of this arrow right here is 1 volt long or 1 unit, then all of the math later is going to be easy. Okay. So we'll do that. And then we're going to go ahead, and now we need to do some geometry. Okay. We're going to draw, we want to figure out what this length is right here, okay, between, on this yellow bar. So we want to figure out what this length is from phase to phase. We know what our voltage is. A phase is equal to 1 volt, B phase is equal to 1 volt, and C phase is equal to 1 volt. We got all that. It's all listed right here, and that's what these lengths are right here, okay? So we understand that, but we want to figure out what voltage A to B is, voltage A to C, and voltage B to C. We want to get those. Actually, some people might get upset with that. Let's write that C to A. Okay. So how are we going to do this? Let's do some geometry. We want to figure out this length. Okay. We don't know what it is, but why don't we just draw some triangles out and figure out what do we know? Okay. We know the length of this side and this side. And then what we don't know is let's just draw an overlapping triangle right here, and we will figure out what these two sides are right here, okay? So now that we have our signs, we're going to assign them appropriately for our trigonometry. And then we can go ahead and look at this, and we'll say H is equal to 1 volt. We know that right here. And so we know that theta right here, if this is 120 degrees and this is 180 degrees, this is a flat line, we know that the remainder right here is 60 degrees, okay? And now you can go ahead and you can figure out with the hypotenuse, H equals 1 volt, and the theta equals an angle of 60 degrees. You can go ahead and you can figure out what the opposite and the adjacent are, okay? And so what we have right here is going to be cosine of theta equals the adjacent over the hypotenuse. And this is our adjacent side right here. Okay, so this is going to be the short little side that we need. And this side is going to be our adjacent, and this is going to be our hypotenuse, and we have our angle of 60 degrees. So we plug all that into this equation right here. Our hypotenuse is 1 volt, right? And so what we end up doing is we divide 1 volt on both sides, right? No, sorry, multiply 1 volt on each side. This is actually times 1 volt, right? Which makes it easier because now it's 0.5 times 1 volt, which basically just says it's 0.5 volts equals A. That's really easy, okay? So this side right here is 0.5 volts, okay? So if we redraw this triangle, it's going to be 0.5 volts, 1 volt, and we just need to figure out what the remaining side is. Let's go and let's do an easy one. This is the Pythagorean theorem. You plug all your numbers, a squared, b squared, c squared. This side right here is actually going to be our a squared, or a, and then this is going to be our b. And this side is going to be our c. And so now you have everything that you need for this formula. Plug everything in, and you're going to get out b equals the square root of 0.75, or approximately 0.866. All right, so now we have this side right here is going to be 0.866 volts. This side right here is going to be our 0.5 volt plus our 1 volt, right? So that's 1.5 volts. And then this side right here is what we're trying to solve for, okay? So we're going to go right back and do the Pythagorean theorem again, because why not? So we assign our sides, got that. You go ahead and you plug all this in, and what you're going to get is this right here: a squared plus b squared equals c squared. You're going to type them in, and you get 2.25 plus 0.75. That equals 3. And if you look real closely, it's c squared. Okay, c squared equals 3. And then when you square root this both sides right here, you get c equals square root of 3. So what we're saying is that if the length of this side right here, our voltage from phase to ground is 1 volt, then our voltage from phase to phase is 1.73 volts, which is the square root of 3 times larger than our voltage phase to ground. Okay, and that's what we're talking about right here. So if you have any phase voltage that you want to use, phase to ground, or B phase to ground, or C phase to ground, it will work for all of them. Okay. It doesn't matter if it's this length right here, as long as it's balanced. And that's what the next slide right here says. This is for a balanced 3-phase system. We're not saying that this is 118 degrees. We're not saying any of that garbage. This isn't 0.95 volts. I could calculate that. That's not what we're showing here. We're saying 1 volt on all of them, 1 volt and 1 volt, and they're each 120 degrees apart. Okay, that's a balanced 3-phase system. So if we were just to go ahead and say, all right, well, this is what my system looks like, it's 120 volts larger. All right, well, fine. It means that A phase is equal to 120 volts, right? B phase is equal to 120 volts, and C phase is equal to 120 volts, right? Then what does that mean? That means that your voltage A to B is equal to the square root of 3 times larger than that, because it's from here to here. Okay, so that would be 208. And that's the same for all of them, every single one of them. Okay, and that's where the delta comes into. So hopefully this helps someone. If you have any questions, throw it down in the chat, and I'd love to hear some feedback on it. Thank you.